Let us review complete concepts about absolute value function. In this particular video, we'll begin with how do we evaluate expressions with absolute value function. We are going to graph interval on number line. We are going to write absolute value inequality in set notation. We'll express absolute value inequality on a number line and graph solutions on a number line. And then finally, we'll understand strategies to solve absolute value inequalities. Now, these inequalities have been seen in the past test paper, and the concepts which we are going to learn will help you get excellent marks. So, let's begin with the review on absolute value function test. Thank you. Let us now evaluate expressions with absolute value. I am Anil Kumar. Welcome to our YouTube channel with thousands of videos for you to practice. Now here we'll just understand how do we calculate the absolute value. It's kind of the beginning for absolute value function. Four questions are here for you to verify the result. And once you've done this, here is an important question for you, and that is, what is the value of square root of x square, right? So what is square root of x square equal to? Is it x? Is it equal to x, true or false? Okay. So that's the question which we will also answer at the end of this video. Perfect. But we'll begin with very small, simple things. The very first one is absolute value of minus 5 square plus 3 times minus 2. So clearly it is minus 5 square is 25, right? Plus 3 times minus 2 is minus 6, correct? So if I open the bracket, what do I get? I get minus 25 minus 6, right? So absolute value, let me write here now, absolute value of minus 25 minus 6, correct? And this is equal to absolute value of minus 31, which indeed is 31, correct? Because absolute value is always positive. Perfect. Okay, great. Next one. X is equal to 7, and we need to evaluate absolute value of 3 minus x. So we have absolute value of 3 minus x, and we have x equals to 7. So let's substitute x as 7. So we get absolute value of 3 minus 7, right? Which is absolute value of minus 4, which is indeed plus 4. So here we know the answer is 4. In the earlier case, it was 31. Perfect. The next example is absolute value of x divided by x for x equals to minus 2, right? What do you expect? Well, let's rewrite this. So we have the question as absolute value of x over x, and x is equals to minus 2. Substituting minus 2, we get minus 2 over minus 2, and absolute value is positive, so it is 2 over minus 2, which is minus 1. So this is minus 1, correct? So it is not that in any question with absolute value, you cannot get a negative answer, right? Perfect. The last question here is absolute value of 2x square minus square root of x square. X is equals to minus 2. Great. So let's substitute minus 2 for x. We get absolute value of 2 times minus 2 whole square minus absolute value of minus 2 whole square. Correct. And we need to find this answer. So 2 times minus 2 whole square means 2 times 4, right? So absolute value of 2 times 4 minus. Now square of minus 2 will be 4 and square root of 4 will be 2. Correct. And so we get 8 minus 2, which is 6, right? So we get absolute value of 6, which is 6. So the answer here is 6. Perfect. Now with that, we come to an end of the solution of these uh, expressions. We evaluated them all. Now the question for you is real test problem. Is square root of x square equals to x? Well, the answer is yes or no. What do you think? The answer is false. It is not x, right? So we know that this is not x. Now, write down in comments why square root of x square is not equal to x. I hope you'll find that interesting and useful. Feel free to share your thoughts. We are going to discuss inequalities with absolute value function. Now, two of these questions have been taken from past test papers. We'll see how to solve them. The very first one is only for the concepts. So let's begin with the solution. The problem here is absolute value of x is less than 5. Now, how is the absolute value defined? Well, absolute value of x is equal to minus x if x is less than 0 and is plus x if x is greater than equal to 0. Now, this helps in solving the inequality. So, normally, how we do it is that we divide our interval into a space which is either less than 0 or greater than equal to 0, right? And the condition here is and, so the inequality should be true for both of them. So, if it is less than equal to 0, the question which was absolute value of x less than 5, less than 0 means absolute value of x is minus x, correct? So, minus x is less than 5. Now, we'll multiply by negative and we get x is greater than minus 5. So, that is the result which we get on the left side of 0. On the right side, absolute value of x less than 5 remains as x as less than 5. So we get that solution. Now, if you look at it on a number line, then what do you notice? Well, the solution here is that if this is 0, then when x is negative, in that case, the solution is x greater than minus 5. So from minus 5, it is greater than, so that means it is this, correct? So when x is negative, I mean less than 0, in that case, the interval which has a solution is from minus 5 to 0, right? So because that is the and condition, it has to be less than 0 and where it is greater than negative 5. So only that portion qualifies for the answer. And on the right hand side, we want it less than 5, correct? So if this is 5, then the two conditions are x is greater than equal to 0 and x is less than 5. So that means this region 0 to 5 qualifies. So for the given inequality, what we have as a solution is the interval from minus 5 to plus 5. Both are not included. Do you see? So we'll have an open circle here, right? And everything in between becomes the solution. Perfect. And so we have the solution on the interval shown here on a number line, right? You could also write the solution as between minus 5 to 5, where minus 5 and 5 are not included, right? So this was a method of splitting the absolute value function by its definition and then solving. Now, I'll show you a very interesting technique to do this in a much better and faster way. So, I'll take a part C first. It looks more difficult. Only reason why I'm taking that is I'll be working on less than, right? So, you see, in part C, the question here is absolute value of 2x plus 1 is less than 11. Now, whenever we talk about absolute value, less than means within, right? So, less than means within. You understand? Within what? Within minus 11 and plus 11. You understand? So that means this 2x plus 1 is greater than minus 11 but less than 11. That is the meaning of absolute value function less than some value. Means within that region, it could be left side or right side. You get the whole idea. So left side will be minus 11. So that becomes our inequality. So it translates into a double inequality. You get the whole idea. So if you translate absolute value of x less than 5 into a double inequality, you straight away get the answer even without doing all the steps which I had shown you. You get the idea, right? Perfect. Now here, let's take away 1. So we said 11 minus 1 is less than 2x plus 1 minus 1, right? Less than 11 minus 1. So that gives you minus 12 less than 2x. which is less than 10, dividing by 2, we get minus 6x, and this we get as 5, correct? So you see, the operations performed are take away 1 from both the sides, right? So minus 11 minus 1 becomes minus 12, and 11 minus 1 is 10. Now you divide by 2, we get minus 6 and 5, and therefore the interval here in this case is from minus 6 to 5. Perfect. On a number line, you can surely show it kind of like this, that it is within minus 6 and 5, both are not included. Now, another important thing which I want to tell you at this stage is a zero test method. Now, zero test, I should say method, or I should say check. Your answer should be checked if the value of x does it lie within the solution. So in our case, 0 is a part of solution. So if I put 0 here, I get what? I get 2 times 0 plus 1, right? Which is 1, right? So we know that 1 is less than 11. So that means 0 is a part of solution. So very fast check, we know the answer is perfectly fine since it also passed the 0 check. Perfect. Now let's do part B, where we're talking about absolute value of x minus 2 is greater than equal to 5. What does that mean? Very important issue. Greater than 5 means away from 5 as well as minus 5, correct? So it really means two things. It means that x minus 2, right, is less than equal to minus 5, or x minus 2 is greater than equal to 5. You see that? That's what it means, away from. So we call this as away from, right? So now it's easy to solve. We'll do x is less than equal to minus 5 plus 2, which is x is less than equal to minus 3. And on the right side, we have x greater than equal to 5 plus 2. So x is greater than equal to 7. So you see how easily we have the solution. X is less than equal to minus 3 and x is greater than equal to 7. Now let's put our solution on a number line. You will understand what I meant by saying away from, right? So it is away from minus 3, away from 7, right? Greater than equal to 7 means like this, right? Filled in, correct? And from here, less than equal to minus 3, filled in. And do you see? It is away from, perfect. And if you apply the zero test, 0 if you put in the inequality, 0 minus 2, absolute value is 2, which is not greater than equal to 5, and therefore it is not a part of solution as clearly shown. The only part of solution is away from right side of 7 and left side of minus 3. 0 is not a part of solution, and therefore using 0 test we could check that our answer is perfect. Do you see that? Now imagine if I would have been answering part B and C also as I did part A, it would have taken so long for me. This is the best method of doing it, and those of you who follow and apply this method will definitely have an advantage over the peers. And that's where we come in. Well, in case you really want to master the strategies, you can send an email on globalmathinstitute@gmail.com. Express using absolute value function and graph on a number line. So we have 6 examples here. The very first one, x is between minus 2 and 2. X is less than equal to minus 5 or x greater than equal to 5. X not equal to plus minus 6. X not equal to 5. X is greater than equal to minus 2 but less than equal to 6. And x greater than equal to 1 or x less than equal to minus 7. You can always pause the video, answer these questions. The last two are kind of challenging questions seen in many test papers. We'll see how do we answer them one by one. The very first one is straightforward. x is between plus and minus 2. You can write this as an inequality, absolute value of x less than 2. So that really means that the value of x is between two numbers, and these two numbers are minus 2 and 2. 2 and minus 2 not being included. So on a number line, you represent as shown here. Clear? The next one is x is less than equal to minus 5 or x is greater than equal to 5. It means away from. You get the idea, right? So here it is absolute value of x is greater than equal to 5. So it is away from. So in this particular case, on a number line, what you notice is that the arrows are pointing away from the numbers minus 5 and 5. Makes sense? Since it is greater than equal to, they will be also filled in. So when we fill in, we include the numbers at the boundary. Perfect. So I think to begin with, these two are straightforward, which give you the definition of absolute value function. Now let's move on. We have x not equal to plus minus 6. How do we write this as an absolute value function? So when I say x is not equal to plus minus 6, then it means we are looking for two values where x is not equal to plus minus 6. So we could say that absolute value of 6, x is not equal to 6, correct? So that really means that two values are excluded because minus 6 will also be absolute value as 6. So that is clear. So on a number line, we are going to represent this as not equal to plus and minus 6 means everything but not plus and minus 6, right? So in between them and away from them, all will be highlighted on a number line. X is not equal to minus 6 and x is not equal to plus 6. That is how you're going to show it on a number line. So far, so good, right? So whenever we are using absolute value function, normally we have two limits. Either it is within those things or it is away from them or at those or not at those, right? Now here is a unique example where we have x not equal to 5. Not equal to 5 is just one value, right? So how do I write it as an absolute value function? Well, on a number line, it is simple. I could say everything but not 5, right? So everything but not 5 means we have arrows on both the sides from 5, correct? But 5 is not included. So writing it on a number line is not a problem, correct? How do I represent it on a as a absolute value function? Well, that is kind of difficult. So, well, as you know, if I write kind of like this, absolute value of x minus 5. So, what is that equal to? Well, the absolute value function has moved 5 units to the right. And if I say that this is greater than 0, in that case, we are excluding x equals to 5 because at 5, the value is 0. You get the whole idea, right? At all other places, it is positive value. So that becomes the absolute value function inequality to represent the situation. Clear? Great. So that brings us to the last two questions where we have x between minus 2 and 6, both are included. So on a number line, let's get those marks first. We have the 2 points, minus 2, right? And 6. So everything in between, including minus 2 and 6, will fill this up, right? Correct. Now, how do I write absolute value inequality when the two numbers are different? So that is very interesting to understand. So I'm going to share with you a tip here, and that is find the midpoint. So what is the midpoint? So midpoint will be add them, divide by 2, right? So if I add 6 and minus 2, I get 4, divided by 2 is 2. So the midpoint here is 2, right? Now, From 2, how far away are these 2 points? So we can see that from 2, this is 4 units, right? 2 to 6, and this is also 4 units, right? So we can see that they are 4 units away. So if I position the absolute value function right at 2, which is to say absolute value of x minus 2, right? And then what I want is that this value should be within 4 units and equal to also because the endpoints are included. Do you see how beautifully and easily we got our solution, right? So that is how we have done this. And now the last question for you is very similar. So I like you to adopt this strategy and do it yourself, right? So we have this number line, and on a number line, we know that x is greater than 1 means, let's say like this, right? Greater than equal to will fill it up, and less than equal to minus 7, less than equal to fill it up. This is minus 7, that is 1. I like you to do this question yourself. Strategy is very simple. First step, find the midpoint, right? Find the midpoint and then see how far are you from the two ends. Makes sense, right? So I like you to do it yourself, take it as a test question, and then move on to the next video. The question here is write a set notation and then graph absolute functions on a number line. So, 5 questions are there. So, the very first one is absolute value of x greater than 5. So, the set notation will be using the brackets, correct? X greater than absolute value of x is greater than 5. It means that x belongs to real numbers, right? Where x is, so absolute value means that it could be less than minus 5 also, right? So it is less than minus 5, or x is greater than 5. So plus and minus is what you get, correct? On a number line, I'm going to sketch it like this. So on a number line, let's say we have a 0 right there, and plus and minus 5 is shown like this. Then what we are saying, absolute value of x is greater than 5 means going away. So away means open circle at 5 and then outside, open circle at minus 5 and towards the left. That is how we are going to represent this on a number line. Correct? Next one here is absolute value of x less than equal to 3. So in set notation, again, x belongs to real numbers, right? And x absolute value is within 3 and minus 3. So we could rewrite this as including, right? So that is how we are going to write this as. So in this particular case, it is within plus and minus 3. So let's say that is 0 for us, and let's write down minus 3 here and plus 3 here. So what we really have is within and including 3 and minus 3. So that means filled in circles, add plus and minus 3, correct? And then join them. So that becomes your solution. Now we have absolute value of x is not equal to 5. It means that x is not equal to plus and minus 5. That is what it really means, right? So in the set notation, we'll write x belongs to real numbers where x is not equal to plus and minus 5, right? Because minus 5 will also be 5. Correct. So here, what do we have? We have this number line, perfect, with, let's say, 0 right there, and plus and minus 5. This is minus 5 for us, that is plus 5. So everything but not plus and minus 5, correct? So we have open circles at plus and minus 5, as you can see, and then we'll include everything else on this number line. Make sense? Now we have absolute value of x plus 1 is greater than 3. Now that is kind of tricky. How do we show this on a graph, right? So I'll show you very beautifully how it can be done without really solving the inequality. right? So let's say this is 0 for us, right? Now, when I say absolute value of x plus 1, that means our vertex for the absolute function is at minus 1, right? So here, let's say this is minus 1, minus 2, minus 3, minus 4. And here we have 1, 2, 3, 4. So this minus 1 is the vertex, right? So from minus 1, it is greater than 3, means away 3 units, right? So 1, 2, 3. So that becomes 2 for us, correct? It is not included. And on the left side, 1, 2, 3, which is minus 4 for us, that is also not included. We have to be 3 units away from here, and therefore the solution should be like this. You see how we have drawn without solving the inequality. And here we get x belongs to real numbers such that x is less than minus 4, right? Or means union x is greater than 2. So this is actually a difficult question. We have shown you how do we do it without inequalities, which we are going to take up in another video on a number line. Perfect. The similar next one is absolute value of x minus 2 is not equal to 0. So when will it be 0? It will be 0 for x equals to 2 only, right? So in this case, the number line is right there, and this is 0. Let's say this is 1, this is 2, 3, minus 1, minus 2, 3. So when we say x minus 2, absolute value, not equal to 0, means it could be anything, right? But not 0. So it is 0 only at 2, right? So at 2, we have to exclude this particular point, and everything else is included. Make sense? So that is how we are going to draw this number line for the given inequalities with absolute value function. Important thing here is that we have solved the last 2 3 questions even without getting into solving inequalities. So we get x belongs to real numbers where x is not equal to 2. Perfect. Because at 2 it will be 0, and we want something which is not 0. So these are the type of examination questions which you see, and they are slightly difficult to answer. The question here is to graph on a number line following 6 set conditions. X such that x is less than minus 2, where x belongs to real numbers. X such that x is between minus 2, where minus 2 is included, and less than 3, x belongs to integer. X such that minus 2 is greater than x, or x is greater than equal to 5, where x belongs to real numbers. X not equal to 3, x greater than 0, x greater than equal to minus 1, and x between minus 4 and 5, x belongs to real numbers, both boundaries included. Let us see how do we graph on a number line the given set of numbers. So we'll have a number line which can extend on both the sides. Number line normally represents numbers in the set of real numbers. And when we want to plot x less than minus 2, let's first locate 0. And then, we can just divide this number line into units. And since we are looking into minus 2, which is second from to the left of 0, and we want x less than minus 2, means minus 2 is not included. Open circle represents not included, and then arrow towards the left. Everything on the left side of a number is less than. So that represents x less than minus 2, where x belongs to real numbers. The next one on a number line. So let's first sketch the number line. We want this time x between minus 2 and 3. Minus 2 is included. So let's again plot 0, 1, 2, 3, 4, and then -1, -2, -3, -4. Now, in this particular case, as you can see, we want to include -2. So, including -2 will be making a solid circle there, right? Filled in circle. You understand? Filled in circle at -2. And we are looking into the set of integers, right? So, we'll not draw a line, we'll just uh, circle the integers between -2 and 3, -2 being included. So that is what we're going to do, right? Not including 3, right? So less than 3 makes sense. So that is how we are going to get the result. So in this we have 5 points. So I hope you have understood the strategy. I would like you to pause the video, answer this question, and then look into my suggestions. Perfect. And those of you who really want to learn, they can always contact me on the email address given, which is globalmathinstitute@gmail.com. So let's continue. We have now to represent x such that -2 is greater than x, or x is greater than equal to 5. So let's say this is 1, this is 2, this is 3. So that is -2. And here 1, 2, 3, 4, 5, 6. Now we want -2 be greater than x really means that x is less than -2, correct? Not including. So once again, we'll do open circle here and move left. X greater than equal to 5 means at 5, we'll do 1, 1, 2, 3, 4, 5. This is 5 for us. Close circle, right? And move to the right. Everything to the right of a point is greater than. So that represents C. D is x is not equal to 3. So if that is 0 for us, 1, 2, 3, 4, let's say this is 3. Not equal to 3 really means that we have a hole here, right? And everything else is included. Correct? Now, for clarity, I'm drawing my lines above so that you can clearly see what we are going to do. But you could draw this line on the number line itself. Perfect? Okay, great. Next one here is x is greater than 0, means this is 0 for us. 0 is not included, right? So sometimes we use the open bracket also. So let me just show you the open bracket like this and then greater than 0. Make sense? Now we have x greater than equal to -1 and x between -4 and 5. X belongs to real numbers. So 0, 1, 2, 3, 4, 5, -1, -2, -3. Right. So what we want really here is x is greater than equal to -1. So this is -1, right? So x greater than equal to -1 means this is included and there it goes, right? And we are also given a clause here, condition, and x is between -4, x is between -4 and 5. So -4 and 5 will really mean 1, 2, 3. This is -4, right? So the other condition given to us is x is between -4, -4 included, and 5. 1, 2, 3, 4, 5. 5 included. So this one. Now, from these conditions, since we have AND condition, we can only take a region which is common to both. Means -1 is included, and then we can go maximum till 5 only. You get the whole idea. So let me use the second nomenclature, which is square bracket means included, right? So we have included -1 and also 5, and that is the close bracket. So that square brackets means we are including. You get the whole idea, right? So This is 5. So the only region which will be finally included will be from -1 to 5. Is that clear to you? Perfect. We are going to use this strategy in solving many problems related to absolute value functions, since we need to give the inequalities many times as a solution for absolute value inequalities. I hope it all makes sense. Feel free to write your comments, share your views. We'll